and you start looking at what you can do. You should have recognized right off the bat that fraction on the right can be simplified out by 2's. Are we okay with that?
Yes.
So as you wrote it down, you should have written it down as 2x plus 7 over x plus 4 minus 2 over 1 is x plus 10 over x plus 4. What's the common denominator? X plus 4. So you have to multiply everything by x plus 4. When you're doing that, you're bringing it to here, to here, to here. You just don't write it, because what's x plus 4 divided by x plus 4? 1. And now you just have a crappy looking equation. Distribute and solve. 2x plus 14 minus 2x minus 8 is x plus 10. What's x? Negative 4. What does that work? Nope. That's an extraneous solution. So there's an answer, but it's just not an answer. Okay? When you're multiplying those things through, that's what you should be doing. You're trying to bring up pairs. Treat it as you would anything else. You're multiplying, you're undoing stuff. Okay? You're undoing it by what gets rid of the denominator. Okay? You're undoing it by what gets rid of the denominator. When you're solving, that's what you're doing. Okay? Excuse me. When you have fraction equal fraction, you just cross multiply. Okay? That one was what? We did 39, right? Is that one of them?
No,
Nope.
sorry, 40.
Okay. I was thinking of the one that was a little weird. Yeah, 45, that's one of them. So, when you cross multiply this out, you have 3x plus 6 okay, big deal. You still FOIL everything like you would normally. Okay. You have a third degree polynomial, which is no big deal. You just have to factor, which we've all done numerous times. So you have 3x squared minus, minus 6x plus 6x, so that just becomes minus 12. X cubed, x squared, minus 4x, minus 4. Okay. Set aside equal to 0, bring everything over. Oops, sorry. X cubed, minus 2x squared, minus 4x. Adding 12 to that gives me plus 8, I believe. And now you can factor it via grouping. Just like you have in the past, it hasn't changed. So you're back to so you have multiplicity at 2, and you have negative 2. Makes sense, because third degree polynomial, you have 3 zeros. Do they work?
Neither
Neither of them work.
or neither, yeah.
Neither of them work. So that's another no solution. Okay. Those 3 answers. They are answers, but they're all extraneous. Okay. Even though it's a repeated 0, it still doesn't work. The idea by cross multiplying, getting rid of fractions, things like that, hasn't really changed a whole lot. It's just that your terms, instead of multiplying by 3, instead of multiplying both sides by x, you have larger terms now. Polynomials you got to worry about. Okay. What else do you want to look at? What was the other one in there that was goofy? Anything? Yes, ma'am. 33. Again, this one's fraction equal fraction. Just cross multiply.
You said 40.
Oh, I thought you said 33, sorry. Again, still fraction equal fraction. Cross multiply. So you're going to get 3x minus 3 is 6x plus 12. Click on the little guy. Move the 12, move the 3, at negative 15 is 3x. X is negative 5. Does that work?
You 40.
Okay. You're staring at it. You all right? Oh, all right. Which one was the intersection? Oh, that would have been 20x equals 3x plus 6. So it would have been what? 17x equals 6. This would have been a crappy fraction. 6 over 17. No big deal. Which one was Sam?
40, but I just did I accidentally did 40 through 45. So 45 through 50.
Oh, that's all right. I mean, here, all same thing. You just cross multiply would have that third degree polynomial. You would factor the aggravated. It should have worked itself out. It shouldn't have been so bad. Let's see. I know. When we did these last, I'm assuming there are still issues and questions regarding just adding common denominator stuff. Okay. Are you shaking your head? Yes. Do you know which one you want to look at? This is 5, right? 95? 28? Okay. No problem. All right. So. Oops, that sucked. Okay. Before we get to this one, I want you guys to remember how you prime factor. You guys remember prime factoring? Okay. So let's say you had 1/4 and you had I think the numbers will work a little bit different. 1/18, and you're going to subtract those.
Yeah.
You had to get a common denominator, right? So you had to figure out what they both went into. One of the ways you guys learned how to do that was writing each of these numbers in terms of their primes. You guys remember that?
Yeah.
Okay. 4, 2 times 2.
Yeah.
Okay. 18, 2 and 9, so it's 2, 2 and 3. I'm sorry, 2, 3, and 3. All right. So when you did this, you would ask yourself, what do they have in common? How many? 1. So what we would do is we would circle what they have in common. That's what they have in common in one set of 2's. So your denominator would have that one set of 2's, and then what's left? 2, a 3, and a 3. Okay. You multiply all that together, that gives you the next number that both 4 and 18 goes into. 36. Okay. So when I look at the 4 has how much of that denominator? It has 2 2's, right? What is it missing? The 2 3's. So the numerator here gets the 2 3's times the 1. The other one has a 2 and 2 of the 3's. What is it missing? A 2. What's 3 times 3? 9. What's 1 times 2? What's 9 minus 2? 7. And that's what you would have gotten. That's, what's that, sir? I didn't, sorry. Oh, no, 9 minus 2, so it would have been, so again, what you're looking at is you're not changing anything that you have done in the past. It's just that your factor terms have parts to them. Okay. What do these guys have in common? A 6. Okay. These guys have a 6. Oops, let me go a bit. They have a 6 in common, because I can circle it. There's one set. What's left? The x and the x minus 2. Fraction on the left has a 6 and the x minus 2. What does it mean?
An X.
Fraction on the right has the 6 and the x. What does it mean?
X minus 2.
And this one's just a little weird because you have to factor or point all that out and then distribute the negative. That's where it can get kind of odd. All right. So FOIL out the x plus 3 and the x minus 2. So we have 7x minus the quantity x squared plus x minus 6. Distribute the negatives, we get negative x squared plus x plus 6. So that gives us a new
It should be negative 6 minus 6.
Minus 6.
No, minus x.
Minus X.
Oh, thank you. No, because I was getting ahead of myself. Thank you. Sorry. So, excuse me. Our new numerator, when I combine that with the 7x, gives me negative x squared plus 6x plus 6 all over 6x plus 2. And I'm done. No. Again, yelling at you for that. You cannot simplify stuff over addition. Okay. Where?
That 7 and
All that junk? Okay. You're okay that this fraction needs the x minus 2, right?
Yeah.
Okay. All I did, I FOILed that out. I got this. Bless you. After that, I had to subtract it because it was minus all that junk. So I just distributed my negatives, and then I combined the 7x with the negative x, and I got my 6. Okay. Okay. And that's how that stuff should look. All right. Each time that you're working through these things, this is how it should go as you're going through. Let's see, same thing. If I look at, I don't know if you have to do this one or not. If I look at one like this, that's an x squared minus 16. First thing you'd be doing as you're writing this down is you factor everything that you can. Now, I've been factoring really fast because we've been factoring for 2 months straight. So we should be able to factor by now. So you have your 2x plus 1 over x plus 4, x plus 4, minus 3, x plus 4, x minus 4. Okay? Start to write out your denominators. What do they have in common? They have an x plus 4 in common. So one thing they have in common is an x plus 4. So what I do is I always circle what they have in common. What's left?
Another X plus 4.
Fraction on the left has what? Has 2 of the x plus 4. What does it need? That was minus again, yeah. And the other one just needs an x plus 4. Combine all your like terms in the top and leave the bottom how it is. FOIL that out, you get 2x squared minus 8x plus 1x, so it's minus 7x minus 4 minus 3x plus 12. Put all that together, you get 2x squared minus 10x plus 8 all over If you look at the numerator then, what do they have in common? 2. Okay. So if you do take out the 2, is that factorable?
Yeah.
What's the factorable 2?
X minus 4, X minus 1.
X minus 1, X minus 4. So we can have before the X minus 4.
Oh.
This is the very rare case that something like this can happen. Okay. This is that weird, rare time that sometimes that does occur. Okay. So you get what happens is graphically, and this is what we'll start looking at tomorrow now, is that there would be a hole in the graph for that, yeah. Literally, there's a hole in the graph.
What is that?
Honestly, it would look something like, as you have the graph, if there's a curve, it could just be a hole. Yeah, it's some weird stuff that can happen. It has to deal with a lot with the asymptotes and stuff that you get. So, but we'll get to it. All right, we'll get to it. Which one? $42? Sure. In 42, there's one property that you probably don't know. The negative exponent. Did we talk about negative exponents yet? It just goes to the denominator, yeah. So this becomes, this is, we still have 1 minus x over x to the 4th all over, this is 1 over x squared minus 2 over x cubed plus x squared. Negative exponent just means it's not happy where it's at, so you flip to the other side. In case you forgot that. So we get this giant fun fraction. Top numerator is not a whole lot you can do with it. But the bottom bottom denominator, there is. One of those things you can factor a GCF, the x cubed plus x squared. I can factor out the x squared. Okay? So if I factor out an x squared, I have x plus 1. Now between these two denominators, what do they have in common? Very good. So here, I have an x squared, I can circle that. What's left? The x plus 1. Okay. Fraction on the left has the x squared, it needs the x plus 1. Since it's just multiplying by 1, I'm just going to write x plus 1. The other side has them both, so all I have to do is just write minus 2. Okay? So that numerator becomes x minus 1. You okay with that? All right. One up top, nothing really to do with it, so I just keep bringing it all the way over. So I have the 1 minus x. All right. Say keep, change, flip. So we have 1 minus x over x to the 4th times x squared, x plus 1, all over x minus 1. Which stuff? 1 minus x and x minus 1 are not the same thing. What do you have to do? You said it. Yeah. You can take out the -1 and then that'll change it. Okay? That's that trick here. You can do a -1 times x minus 1, and that would give you this. That's the trick. So you can do that. Now you can go no. So now you have -1 up top. X squared over x to the 4th, who wins the battle? So what's 4 minus 2? 2. So this guy goes away, and this becomes 2. So now you're left with -1 times x plus 1 all over x squared. Okay. You don't have to distribute the -1. I mean, if you do, it's something. It's becoming unfoggy.
Yeah.
Oh,
So you also signal that
multiplication of circles. Yep.
when you do this,
There's an equal sign, then you're. If it's fraction equal fraction. Does that work? All right.
So, okay, when you have
Hold up, guys. Hold on. Go ahead.
when you took out the x squared and then the x plus 1.
Here. Oh, here? Yeah.
Yeah, you didn't have to worry about the x cubed plus the x squared.
Nope. Because I just factored it to that. Just like how we did before. Whenever we had something that was kind of funky looking, if I had, x squared minus 5x minus 14, I factored as I'm writing it down. In this case, I wrote it all out first and I said, I can take GCI. And I just wrote it right underneath it real fast. Okay. It's very common thing. All right, it's very common. Let's see, what's the other one? I don't look at that. Oh yeah, look at that. Difference of cubes or sums of cubes. Huh. That doesn't go away, does it? No. It does not go away. Which means you have to figure out what's the cube root of 64. 8. 4. All right. So first thing you do, this is 1 over x plus 4. X squared minus 4x plus 16. Okay? Have you factor that? That's the pattern of that you have to remember. Down here we know we have x plus 4, x minus 4. And then this one is a 3x and then x plus 4. What do those guys have in common?
X plus 4.
They have an x plus 4, good. So we circle the x plus 4 because that's what they have in common. We write it down. And then what's left? X minus 4 and a 3x. And I usually put the 3x in front of everything just because it doesn't need the parentheses. Okay, remember the order in which you multiply never matters. Okay? And now you just go through the process again. What does the first fraction mean?
3x.
It means 3x. It has the 2 parts. So it's going to be 5 times 3x, which is 15x. Fraction on the right means the x minus 4. So you have 2, as you write up with 2 times the x minus 4. Okay? When you distribute that -2, you get -2x plus 8. All right? So that numerator, as we start to rewrite and flip things, keep change, flip. And then that denominator becomes -13x plus 8. What's the only thing I can simplify?
X plus 4.
I can only simplify it like x plus 4.
And then
Okay. And then obviously, I think I've told you guys just multiply out the top so you get 3x squared minus 12x. That's what that would look like. It's not. Okay. There's a lot of factoring. Doesn't go away. It's factor, factor, and factor. When you're done factoring, you probably have to factor again. Great factoring. Okay. What's the other one here? Another example. Remember, another example of solving. What are you going to multiply everything by? Well, what is x squared minus 1?
X plus 1, X minus 1.
It's x plus 1, x minus 1, isn't it? So you would multiply everything by x minus 1, x plus 1 to get rid of it.
Wow.
It. The idea is you're trying to get rid of the fractions. What do you multiply by to get rid of it? Well, to get rid of everything, you got to multiply everything by x minus 1, x plus 1. Okay. First fraction has an x plus 1, it needs x minus 1. So you get 2, x minus 1. X plus 1 equals 2. Distribute and solve. I just brought the 2 over because I knew I had said equals 0 eventually anyway. So you have x squared plus 3x minus 4. What times what's negative 4? You have to together get positive 3. And it gives you zeros at?
Negative 4x minus 1.
Can't have it at 1, so.
I think we can graph it.
Okay, so you had. What blanket? You sure? You're not sure you want one blanket? Okay.
It's just funny, every once in a while you see him just going.
Alright. All the. Hello, sleepy. Hello. He's so very sleepy. I don't care. You can leave whatever you want. I think it's frowned upon. Certainly. Alright. What other style you want to look at? Because I got some more extra of these on a sheet too.
What I did is I just kind of quickly put together good old buttons on CUDA to try and get you through a few of these. On the calendar is the same sheet, but I did post the solution piece, the page to it is on there. Not worked out, but it just gives you the answers, so you can check them through. Like I say, just when you're trying to break them down to get your common denominators and stuff like that, just take your time, factor as you go, and go through that, especially for the adding and subtracting ones. Multiply and divide, you're just factoring first before you do anything, but then you go from there. Those are the easy ones, multiply and divide. Okay? Yeah, hopefully this shouldn't be so bad. And I just wish it would just let me use X all the time, so I don't go with others, but whatever. All right. First world problems.